anybody? Rosie? Hey, doctor.
Yeah.
So,
Yeah.
okay, so I'm gonna leave this whole thing up, this board right here that has all kind of like the how to get it done and the conversion between exponents and logs, and the phrase of how to remember what order things go in, and then how to do things in the calculator in case we need to. But I think kind of looking back at this, I know these are different questions potentially than we did yesterday because this was from 7. Do you have any kind of like glaring standout questions right now about what we did yesterday that confused you a lot? Before I go through a couple, just to see it again, and then I'll give you a handful or two to try in your own. We'll call it a day. Is there anything from yesterday that was confusing, that you don't understand, that you want to get off your chest now? I know it's new, but if you can kind of get over the hurdle of this whole log base v of n kind of setup, where the answer to a logarithm is just the exponent, you should be okay. With that, what I want to do is just kind of do a couple examples, an easy one, maybe a medium one, like a hard one, and I'll make some up for you to try, and we should be good to go. So if you're good, I'm good. I'm going to start fresh. Again, I'm just going to kind of call them, examples as we go, and I think that's the best way to do it. Definitely want to have a calculator out, ready to go for when the time comes to try to find that answer, whether it's going to be nice or not. You can let the calculator do it. Like I said yesterday, if you know what the exponent should be, because it's something you know, great. I don't need to see the log. But it's always safe to make that switch right there. Now, it's a new day, so I'm going to start at number 1 again. Let's start simple. Again, you might see some repetition because there's only so many nice ones that I can make up. I don't know. 6 to the x equals 36. Can you look at that and know what the answer is supposed to be? What is it? 2. Done. X equals. Now, just for good measure, let's see if we can make the switch from exponential form into log form and just make sure that we get it right. And I think the easiest way to do that, right, base, exponent, and then the answer to that, b, e, and n, can we figure out what those 3 are and then make the switch to log? So what's the base in this case? 6, good. What's the exponent? X. And then the n? 36. What's that n again? What's that called? Argument. Yeah, that's the name of that n. I'm going to call it the argument. Good. So now, right, this was in kind of Ben form, right? Now what we want to do is make the switch from Ben into log banana. Okay, so log, and then down below, right, not in line with the log, we're going to drop it down into that little subscript spot. That's where the 6 will go. And then the 36 goes in parentheses right there. And that's equal to. And we should be able to jump into the calculator. Mine's charging right now. This is right here. And press all of the right buttons to be able to make sure that, yes, in fact, we were right. That exponent is supposed to be 2, and that's right here, right? Press the math button. Scroll down the log base, and then make it match. 6, right arrow, 36, press enter. Voila! And we're good to go. But again, that whole log stuff in between, I don't need to see if you can do that in your head. Can somebody read this out loud, though, this whole log thing? See if you can say it well. This is the easy part. Log, there we go. Base 6. No, log base 6 of 36 equals. So x equals 2. None. Minus is good. Okay. Let's try a similar one. 6 to the x equals 35. Is our answer going to be 2 bigger than 2 or smaller than 2? What do you think? Less than 2, right? Because if it was 2, I'd get 36. I didn't get quite to 36, I got to 35. But it should be pretty close, right? Like 1.9, 1.8, 1.95, you know, somewhere in there. But I don't know this off the top of my head. Now, that doesn't mean there's not a nice answer for it. We just have to check to see what happens when we make the switch into logs. And the easiest way to do that, I think, is to write down what your base, what your exponent, and what your argument are, what those 3 things are, and then make the switch into logs. Question? Yes. So what's the base here? Exponent. Argument. There we go. Okay. Now all I have to do is put all the right things in the right place. This is kind of what it always looks like. A log equation is just going to look something like that. Okay. Something in the base, something for the argument, and then something for the answer. So what should go here? Down here? 6. Log base 6 of, right, these kind of switch places equals x. That's nice. Now we try. Log, oh, not the log button that's on there. I got to go math. Log base 6, right arrow, 35. What'd you get? Blah, 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 but it keeps going, right? So what's, but we were pretty close, right? We knew it was a little less than 2, but it was really, really close to 2. So should we write that decimal? Done. If it bothers you that the x is on the right and not on the left, then just switch it. You don't like the fact that it's not x equals, then rewrite it. It's up to you. It's the same thing. Equals x equals 3. Okay, so nice answers, we'll use them. Not so nice answers, we'll just use the log version. Okay. I don't know, let's do one more. 2 times 4 to the x plus 3 equals, CJ, give me an odd number. Make it like more than 7. Now, 1 and 2 are ready to go, right? Step 1, isolate that base in that exponent. Make sure that's the only thing on one side. It started that way. It started that way. So we didn't have to do anything first. It was, all right, I'm just going to make the switch right away to log, or check it out and see if I can come up with the answer just by looking. Like the first one we could, right? Second one we could. But 3 is not ready for that switch yet between exponentials and logs. You've got to go through the process of getting it alone first. Then we're good to go. So 2 times 4 to the x plus 3 equals 3. What do you think? What should we do first? What? Not add. Do the opposite, starting with addition subtraction first. The way it goes. 2 times 4 to the x. Again, I like that dot a lot in between. It helps remind me that the x is really only attached to the 4. That is not like 2 times 4 to the x. It's not 8 to the x. The only thing going up to that power of x. 4. So that's the base that I'm trying to get by itself. Next. If it goes in nicely like this, great, we'll do it. If it doesn't, then we'll just write the fraction. That's okay. We're gonna see that we can have arguments that are fractions, 10 over 3 or something. What's the number? So 4 to the x equals 5. Do we know that one off the top of our heads for sure? No, 4 to the first is 4, 4 squared is 16, so it's a little bit more than 1, definitely less than 2, but like, is it exactly like 1.5 or 1.2? Who knows? You gotta try this stuff out. This is not the kind of thing where you'll know for sure what the answer is exactly without trying it out. Base, exponent, argument, figure out what those 3 are, and then make the switch. Seems to be a pretty good strategy. And then let the calculator kind of work from there. Now, maybe you don't have to write out B equals, E equals, N equals. You just know what they are. Great. You can look at it and know that that's the order that they're going in. I'm cool with that. If you want to just be able to jump right to here. Awesome. If you need to write this down every single time, great, do it. Right, you need to write down log the name. It's the same thing then. You can easily make the switch between the two. Like these 2 equations mean the same thing. It's exactly the same. One just isolates the exponent. Now check it. Bigger than 1, less than 2. Probably like not much more than 1. Let's see. Base 4 of 5. Yeah, 1.160964 04. No. Next. This one. Good? Questions? All right, let's get after it. I'm going to give you a few to try, not too many. But I am going to erase these, if that's okay. Can I get rid of these? Because I want to keep this up so we can look at all right. So that was 1, 2, and 3. So we can start calling them like 4, 5, 6. Let's see. Start with some easier ones. We'll go 5 to the x equals 1.5. 4 to the x equals 2. 7 to the x equals 35. 7, 9. What time we got here? 10? 15. We got a little. We got plenty of time. We might be done a little bit early. 2 to the x plus 5 equals times 4 minus minus 1. Medium ones. Now let's ten, 11. Okay. 9 of them to try. That should get us plenty of practice and get us to the end. And we'll talk about it. I'll put up some answers for the first 3 really soon. Those go pretty quick. Sorry, what? I think he was like 1 or 2 when I got him. Not a whole lot longer. I think he was like would be maybe 8 or 10 years old. He just has his food in there. Yeah, he's hungry. Really? How not? Yeah, all right, first 3 answers coming up. Yeah. Okay, so all the calculator stuff is right here. On how to type it in. So below the alpha button, the green alpha button, is the button that says math. Click on that. Once you get into that math folder, scroll down to the option that says log base. And it should kind of lay out like a blank spot for your numbers. You type them in and press enter. Like log, please. And then right here, or you get a nice number one. You don't use the log. Perfect. Which makes sense because 5 cubed is 1.5. 5 times 5. Yeah, calculator can help you for sure to make sure you're getting the right answer. To make sure 4, 5, and 6 look good before you move on. You get 0.5. Oh. So I use the fraction version rather than the decimal for a couple of reasons. Number one, fractions for me are just, I like see them easier, I can understand them a little better. That's the first one thing. The other reason, we learned that exponential fractions power over root. Power of 1, root of 2, the square root of 4, 2. And it just kind of like clicks better for me when I get an answer. For an exponent, I write it as a fraction, like, what does that answer mean? In this case, it's the square root. That's what this means. Take the square root of 4. But the decimal's fine. You write the decimal. No, if you want to put 0.5 for number 5, that's good too. They are one and the same, so that's good. Calculator is going to give you the decimal version, unless you change your setting. No. He's super laid back.
You take a finger off it.
No. Not unless you were a cricket. If you were a cricket.
Yeah.
Let's see. Eight. Nine. Don't just write my answers down. Make sure you can get there. Because tomorrow we'll go the other way. We'll solve log equations by switching it from log to nay back to that. It's the same thing. Like your variable is stuck in a log, I use exponent. He won't go anywhere. He won't jump off. And if he does, you know what? He'll be just fine. He falls off of there all the time. You like to rest like on your chest, your shoulder. If you want to put them on you, feel free to do that. The nurse's son graduated from Ponderosa about 3 years ago, and couldn't take him to college. Let me know if you need any help. If you're not getting these answers, you're not sure why. They're talking about. I'll put up an answer for 10. Let's see. I'm going to need logs. You can see that, okay. For a log, and so the vertical asymptote is the y-axis unless there's a polynomial. So if y equals log base of x.
Yeah.
But if they did like y equals log of x is minus 4, that's a polynomial shift, like 4. That's really all you have to do is set your argument equal to 0. X equals the vertical line. So the x-axis is equal to x equals whatever that is. Yeah, looks good. Yep. So but we're not quite done yet because the goal is to get x equals x equals x equals x equals. Your variable is still stuck with the exponent, right? So but you got the base and the exponent isolated. It looks like this. Now we rewrite it like this: log base b of n equals b, which is your exponent. And you're good to go.
Calculator stuff?
Well, you want to rewrite it first and then check it in the calculus. We make the switch, right? It's in exponential form, and it's not an answer I can just look at and know, right? 4 to the x equals, or 3 to the x equals 1.5. I don't know what that is. That's not one of my numbers that I know, so I'm going to rewrite it like this. Then plug it in the calculator. If I get a nice number, I'll use it. If I don't, then I just leave it as a line. Yeah. So it's already set up, right? It's base, exponent, argument, so I don't have to do any rearranging. Log base 7 of 0. Yep. Yep. Equals. What'd you get? This is not a number. That was a number. Well, check it. Always want to check. Something kind of weird happens with 11 and 12 that I think is worth talking about. Take a picture of these questions. Like the local maintenance. Really? Yeah. They're territorial, I can sure. But there's only one to a cage. Yeah. Yeah. Love it. So we gotta figure out how to say that. I mean, think about it. 7 to some power is 0? Is that possible? Can I take 7, raise it to a power, and never get 0? We're not always going to get, like, not every equation has an answer, and that's what I want. So, yeah, I'd say no solution. But we'll talk about that in a moment. Yeah. Yeah. When you get back, we're talking about how to wrap this up. Make sure you at least get 4, 5, 6, 7, 8, 9, and 10 done. Because I want to talk about 9 specifically and why we end up getting just 0. And then I want to talk about 11 and 12 and how a certain setup of a problem might cause a problem. Depending on what it is, bring something else. The whole thing Yeah. You got what? Negative infinity. For which one? For 11? Negative infinity. How do you even get that? That's kind of crazy. Well, so what does that mean then? 7 to the power of negative infinity. Well, let's see why they gave us that. Well, remember, negative exponents needs to do 1 over 7 to the infinity. 7 times 7 times 7 times 7, 7 times 7, 7 times 7, forever. What do you think that's going to be? Really, really big, right? So big that there really is no number for it. Okay, so we've got this fraction where the denominator is really, 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 really big. So 1 over a really, really big number is really, really, really small. How small? That's small. But here's the thing. Is that a number? And so can I say x equals negative infinity? Can I give a non-numerical answer to a problem like that? There is, and so here's the thing I want you guys to see. If you haven't done it yet, take a look at 11. Some of us are getting like not a number. Some of us are getting answers that really just weren't represented with numbers because it's impossible. I can get really, really close to 0, but we'll never get there. Remember, you have a horizontal asymptote, right? A line that a graph approaches but never reaches. This is exponential. We're never going to get there. No matter how many times I do this, 1 over 7 times 1 over 7 times 1 over 7 with the negative exponent, never getting there. Get really close, but never getting there. What about this one? Can you raise a positive number to a power and get something negative? 7 times 7.
I got like 0 plus 1.
Can't do it. Can't be done. There's no way to raise a positive number to a power and get 0 or anything negative. Everything else is good though. And here, the negatives ended up canceling out, which was nice. So that's why we were able to get an answer. Yeah. See that little I at the end? That's an imaginary number, which is not the world we're living in. So when I say no solution, what I really mean is no real solution. There's no actual real number that we're using. I think, because this is going way faster than I ever thought it was, we'll get to those kind of numbers at the end of the year. I'm going to talk about what there's not really a whole lot more that I can do to mess with this and make these a whole bunch harder. So I'm good. Yeah. No, this is just practice for today. Nothing you have to submit, but hold on to it for sure. We're done early, so hang out for the next 5 minutes. On Sunday, cold, so built some fire in the fireplace. I want to just like help out. I really get to see my family.
So we went up there on Sunday and I was at Franklin. 10 minutes.
It's so icy. So like, trying to go through the 86, to go on sale, right before 86, my back tire, everything just started spinning, and there's like, ditch, like a whole gas pipe over here, I'm like,
Nope.
I was sweating. No, fine. They were, my dad was like, when I started driving the car, but it was actually here.
last time I spent it on that road, I was like,
Yeah, you don't want to always.
I do it once a year.
That should be a pipe list. Just trying not to.
Yeah.
We are good to go. I will catch you guys tomorrow.